Okay, children, I already taught you about the concept of this chapter, alright? And you know very well your book is completely related with CC pattern, right? That is the continuous comprehensive evaluation. Therefore, the concept and activity method we have to go, right? So we have to teach the concept at first, then this concept how it is related with the activity, right? So children, I already taught you about the convex and the concave. I am always telling that means you may or may not understand the concave means what or convex means what and what is these mirror are related with your life, right? And sometimes have you saw children your mirror, now your image is bulging sides, and sometimes if you are looking your image and it is also looking smaller size, what is the reason behind it? Okay, and just I am giving one example. When you are buying a new spoon, what is the size of the spoon? Just you see, look my hand, and it is like this. The spoon is like this. So this surface of the spoon is called as the concave surface, right? And the back of the surface of the spoon is the convex. Just you see, when I make straight my hand, so this is called as the plane surface, right? Just this is a simple example I am giving you, right? And then the concave surface, through the concave surface, if you are looking your face, then the image will be bulges. That means bulging means what? It is increase the size of the image. And when you reverse the spoon and look your face, then the face appearances will be diminished, and it is smaller size. It's become the smaller size. And by the help of the plane mirror, when you are looking your image, so your image just it is similar to your face, right? So this is the main differences. And another one application of the mirror I want to tell you, that is the car mirror, right? Car or bike mirror, side mirror. This is called as the rear view mirror. And how this mirror is, which type of the mirror it is, and these are the convex mirror, right? So the bike mirror and car mirror, the rear view mirror, these mirrors are called as the convex mirror. And due to the convex mirror, so back of the car, if any vehicle is there, suppose lorry is there back of the car, bus is there back of the car, then these are image is the smaller side. It's looking like a small size of the image, but by the help of the convex mirror, you can look the broad area, you can observe the broad area, you can see the broad area, right? And this is the main application. And another one application I want to tell you, this is the most important application of the concave mirror. Concave mirror uses by the doctors, right, and a dentist, right? And when they are keeping the concave mirror side of the teeth, then the size of the teeth image, it is a bigger size of the image, the enlarged image you can able to see. So this is called as the convex mirror. This is the convex mirror, concave mirror. This is mainly. And the next, today I am giving one example to you by the help of the activity 1. By activity 1, I want to teach you how can you decide the pole of the mirror and as well as the center of curvature of the spherical mirror in activity 1. In activity 1 in your book given, children, you see here, suppose it is a rubber plate, right? A rubber plate is the flexible, you can bend it. Like that you can bend it, and like that you can bend it. So it is a rubber plate, suppose, right? And over the rubber plates, and you fix pins. Suppose 1, 2, 3 pins you fix over the rubber plate, right? And just I am drawing by the help of diagram. It is a straight rubber plate, right? and on the upper surface of the rubber plate just you fix 3 pins, one first pin, second pin, and another one is the third pin. Just you imagine here, this is the plane surface of the rubber plate, right? And these pins are incident light ray. These pins are incident light ray, and these incident light ray all are parallel to each other. All are parallel to each other. And when incident light ray falling on the plane mirror, again the reflected light ray will be rebound back on same line. Same line. It does not change the direction. It does not change the direction. This concept already you are studied in the 7th standard, right? And similarly, the second pin, it is the another one incident light ray. This incident light ray, when travel straightly and falling on the mirror, again it will be rebound back on the same line. Next, another one incident light ray, when it is travel straightly and perpendicular to the plane mirror, again it is rebound back on the same line. So these incident light ray and normal, how you draw the normal, that is also perpendicular. There is the angle of incident, you cannot find the angle of incident. It is, you cannot say it is 0, because the normal, over the normal, where the incident light ray travel and falling on the reflecting surface, again the reflected light ray rebound back on same line, Okay children, so this is the, what I give an example, this is the rubber plate, right? And this rubber plate, if you are, suppose I show you that it is a rubber plate, right? And if I fold it like this, then what will happen? It is become the convex. It is how, what is it is become? It is become the convex surface. Convex surface means what will happen? These pin direction will be changed like this. These pin direction will be changed like this, right? And when the direction change like this is called as the diverging. This is called as the divergence. Then how can you got what is that? How can you got the center of curvature? You extend this line and back. You extend this line very back, and this line also you extend very back. And when these all line are intersect at a point, then this is called as the center of curvature. Clear? Next, another one things I want to say you, how can you decide the center of curvature of the concave mirror, right? So this is the rubber plate, okay, and the pins are there, and I already told to you the pin are fixing over the rubber plate, and when you are bend inwards, right? Inward, that is the, this is the outward bending, and this is the inward bending. When you are bent like this, then what will happen? Suppose pin here, here and middle, 3 pins are here. Just I want to represent it for your good understanding. So the pin become like that. It is become like that, right? And how you can get the center of curvature? Just you extend this line, right? Just you extend this line forward, then all the line will be intersect at a point, then this point is called as the center of curvature. Okay children, so center of curvature, from the center of curvature to the curved surface, so when you draw line, so this line is called as the normal line. Okay, so are you understanding clear how you have to draw the normal line? After that, then I want to teach you how can you imagine normal line by the help of the geometry, right? Just I am drawing a circle, right? It is a circle, and then over the circle I draw one tangent, right? Tangent, simple touch the curved surface of the circle, right? I am drawing clearly. Next, and this is the point, and next the center of curvature. Center of curvature to the tangent point, where it is touched over the surface of the circle. From there to, if you draw one line, then this is also called as the normal line, as well as called as the radius of the circle. This is the radius for the circle. And if you are taken the curve part, simply the curve part from the circle, then it's become the normal line to the concave surface or convex surface, right? Are you understand very clear? Activity 1, I tell you very clearly about the radius of curvature, as well as I clearly inform you about the normal line. Then I already said what is the difference between the radius of curvature and the normal line. So the radius of curvature, it is represented by r, and the normal line and radius of curvature for the case of the concave and convex mirror is same. There is no any differences, right? And now I want to teach you very clearly by the help of ray diagram the role of radius of curvature and normal line, right? Just you see here. Suppose it is a concave mirror, right? It is a concave mirror. Then this concave surface formed by the center of curvature, children's, right? And this is the imaginary center. What I said, it is a pole. So the pole to center of curvature, this line is called as the radius of curvature, right? Next, if you draw a straight line over the radius of curvature, then this is called as the principal axis, right, children? Just I am giving you a simple example. That is, suppose one object is present beyond the center of curvature, right? This is the object. I said to you, it is a object, right? And from the object, one incident light ray coming from the object, it is parallel to the principal axis. It is parallel to the principal axis. And you have to draw now normal line. Normal line you have to draw. How you have to draw the normal line? From the point of incident to the center of curvature, right? From the point of incident to the center of curvature, you draw a straight line. Then this is called as the normal line, right? And by the help of normal line, you can easily decide the angle of incident. Then this is the angle of incident. I already teach you. Next, you have to draw the angle of reflection on the reflected light ray, right? This is the reflected light ray. Reflected light ray when intersect here, then here is formation of what? This is called as the focus, right? When the reflected light ray intersect over the radius of curvature, then this point is called as the focal point. Clear? So the focal point. Okay. Now another one ray I am going to draw, and from the object, O dash is the object. From the object, another one incident light ray travel through the focus. Travel through the focus. This is the incident light ray. Travel through the focus. This is called as what? Incident light ray falling on the reflecting surface of the concave mirror. Then this is called as the point of incident, right? From the point of incident to the center of curvature, you have to draw what? The normal line. For what purpose you draw the normal line? You have to decide the angle of incident, right? So this is the angle of incident. So according to the law of reflection, angle of incident you know very well. Angle of reflection, definitely you draw the reflected light ray like this, right? Reflected light ray like this. Just you see here, this is reflected light ray and this is reflected light ray. These two reflected light ray when intersect at a place, this intersecting point is called as the image point. This is called as the image point. From the image point to the principal axis, okay, and when you draw one line, so then this is called as the image of the object, I and I dash. It is the image of the object. Just you see here, here is the object above the principal axis, O and O dash, right? So this this position of the object is called as erect object. This is called as the erect object because the object present above the principal axis. This is the erect object. Erect object, then when the image formed below the principal axis, then this is called as the inverted image. Inverted image. Okay, this is the erect object is in the erect position. This is the inverted position, right? So just you see here, when the object present beyond the center of curvature, then the image formed where? Between the focus and the center of curvature. And the nature of the image is what? Image formed below the principal axis, therefore it is called as the inverted image, right? Inverted image. And it is also real image. Just you see, if you are placing one paper piece in front of the concave mirror, then you can catch the image. Okay children, this is related with your activity 1.